Alright, hello everybody. This is Miss Summers. So you are in my third or fourth block and you have just taken your Lithosphere Part 2 quiz test thingy, whatever you want to call it. And you are now going to independently take some notes so that we can catch up from the days that we've missed due to the weather. So, the unit that we're starting is human impact in the lithosphere. And in order to appreciate all that we're going to talk about, it's important to first talk about human population. So, by the end of this, you should have some grasp on patterns of human population, factors that affect it, so why are some places growing faster than others, and some potential consequences. So let's start with what is the current population of the whole world all put together, all of us. And as of right now, there's about 7.6 billion people on Earth. Now, when I wrote this PowerPoint a year or two ago, that number was only 7.4 billion. So, overall, is the population growing or shrinking? Growing or shrinking. And you can tell what it is. If I go to this little website right here, this is a really nifty thing. It's worldometers.info. This tells me that the world's population is somewhere around this number. And as you can see today, there's been almost 190,000 babies being born or have been born. And about 78,000, so probably by the end of today, over 80,000 people have died. Which means overall we are adding people. We are adding more people than are being taken away. Now, has it always been like this? That's a good question. So we're going to go to this clip. It's a snazzy little video. About world population. So let me pull it up. I'm not going to have the sound on for you. So just take a look at what happens. I'll put the CC on for you right now. Give me a second. Bye-bye. I'm making a video right now. Alright, so what's going to happen in this video? What's going to basically happen is you're going to see a picture of the world. Let me turn the CC off. You're going to see a picture of the world, and there's going to be little dots that represent like groups of people of 1 million or more. And I want you to be on the lookout for when in history did we have big growth or lots of growth? And were there any times where you didn't have growth or maybe the population went down? So this will go from 1 CE, which is basically like year 0, up through 2050, so a little bit into the future it projects. And in the corner there will be like historical notes. So just take a look at what's going on when you have lots of people. All right, so here's the Han Dynasty. The Han Dynasty, for those of you that aren't familiar, was a Chinese dynasty. Pretty big deal. You see a few little dots popping up here in Europe. You can see there's not really a whole lot going in Australia. Not really a whole lot going into the Americas. See the Roman Empire. It's popping up around Europe. You see a few more people popping up. So this is about 300 AD or CE. Okay, the golden age of India. Again, most of India's population is concentrated up here in the northern part. And the Mayan Empire, the rise of the Mayan Empire in Mesoamerica. So again, holding strong there. Got a few million people over here. Let's sort of zap through. I'm going to skip a few hundred years if that's okay with you. Oh, there we go. You see a lot of growth here in India right now. The Viking conquest, so people start spreading out. It's believed that the Vikings were actually the first Europeans to make North America, not Christopher Columbus. Alright, so we got trade going on here, Trans-Saharan. So here's the Sahara. See a lot more people popping up. And the Crusades. You had European soldiers invading Jerusalem. The Mongol invasion. Look over here. Interesting. So the Mongols invaded China around 1200. Black Death, the Black Plague. Look what happens in Europe. Oh, where's everyone going? They're dying. That's what's going on. So we'll skip a couple hundred years now as well. The Atlantic slave trade. People are starting to populate the Americas a little bit more. Colonial America. So people starting to live in what's now the United States. Ooh, now I'm going to let it roll. The Industrial Revolution starts in the middle of the 1800s. Modern medicine is invented at the turn of the last century. Right now we're at 2 billion people, 3 billion, 4 billion, 5 billion, 6 billion. So now we're modern day into the future. So by 2050, which is really not that far away, that's only 30 some odd years away, you have a lot of people, about 9 billion, scattered all over the world. So let's go back to our little PowerPoint and answer these questions. Historically, there's 2 events that caused major population increases, all right? It was really, really slow at first, but when you had the Industrial Revolution happen and modern medicine, so people start living in big cities and people start surviving longer, population exploded. Really, the only time that you had any noticeable decrease in population on a global scale were 2 things. One was that Mongol invasion of China, and the other was the Black Death in Europe. And it's estimated that anywhere up to 75% of the European population died because of that disease. So disease plays a very important role. All right. So now that we know that overall population is growing, let's talk about types of growth. So our first one is exponential. All right, exponential is called a J-curve, and it looks like it's called that because that's what it looks like. All right, you might have talked about exponents in math class, or exponential growth or exponential decay in math class. Basically, you start off really small, and then the numbers get really, really big really quickly, and that's what happens here. There's rapid rates of growth, and that shows you that there are lots of resources. So there's space, people are reproducing. But the problem with this is it can only last for a short period of time. You can't grow like this forever. So here's a J-curve. So time is your independent variable. That affects your population size. If you have exponential growth, as time goes on, your population gets really big. All right. But as I said, that type of growth can't last forever. The other type is logistical growth, and it's called an S-curve, and you'll see why in just a second. So the growth rates will start to slow down or decrease as we reach carrying capacity. And with things like plants and animals or other animals besides people, we can observe this, and it's a long-term pattern. All right, your carrying capacity is just what it sounds like. It's how many individuals, so how many people or things that the environment can support or hold. So some factors that are going to affect your carrying capacity, things like food, how much food is there, how much space is there for people to live, how much water is there, things like that. And here's what an S-curve looks like. Oh, no, JK. Basically what it looks like, so imagine this is a graph here. You start, it goes up, and then it plateaus or goes flat. So it looks kind of like an S. Now, the question for scientists, oh no, I lied. Here's your S-curve, LOL. So, increases and then it decreases as you get to carrying capacity. So, here it is. The question is, what is the carrying capacity of the Earth? So I had this article in here. You're free to read through it more in depth than what I'm about to. But the question is, how many people can the Earth support? And it's a really interesting question because nobody really knows the answer. In the 1700s, this guy named Thomas Malthus, he was a fancy pants philosopher. He basically wrote a paper saying, hey, if we don't stop making babies and do something about population, we're going to overpopulate, we're going to use everything, and then everyone's going to die. Basically what he said. So why can't we exactly calculate the Earth's carrying capacity? Is because humans have this really cool ability to change the carrying capacity of the Earth. Right? Because we have so much technology and knowledge at our disposal, we can take a field and we can make it produce more food than it normally would. The question is, what is the upper limit on that? And we don't know. In that article, it says most scientists agree around 9 or 10 billion. And we're getting pretty close to that number. It's not going to take long to get there. So, we know how populations can grow, either exponentially, really fast, or logistically, where it sort of slows down. We know that the Earth is experiencing an exponential growth right now, and the consequence of that is that we might run out of stuff. So let's look at how we analyze certain populations and how they're growing, because not everybody is growing the same way. So we are using something called a population pyramid. So a pyramid, think about like the pyramids in Egypt, where they kind of look like triangles. Some of them look like that, others don't. But basically it's going to show you how many people you have based on their age range. So are they babies? Are they little kids? Are they like your age, like teenagers? Are they my age? Are they old people? And by their sex. And sex means male or female. So are you a boy or a girl? And we can use this to tell if a population is growing, if it is stable or staying the same. So stable and same are the same thing. Or if it's shrinking, because there are places where they're losing people. So here's your basic breakdown. For the most part, girls, this is a sign for female. It's a sign of Venus, actually. Girls are going to be on the right-hand side, and boys are going to be on the left. The ones down here, all right, these little bars are the age. So you're going to have babies down here. So 0 to 4. Here's 5 to 9-year-olds, 10 to 14-year-olds. And it gets older and older and older, all right, until you get up here to the top. Here's an interesting observation, just fun to point out. So up here at the very tippity top, you're going to have your oldest folks. And what's interesting is there's almost always more ladies up here, more girls than guys. And part of the reason is that women typically have longer lifespans. It's just a scientific fact. Why? There's lots of reasons, but let's move on. Okay, so our first population pyramid that you need to know looks like a triangle. You have a lot down here and very few up here. So many young people, they have what's called a high fertility rate. And a fertility rate is how many babies on average a lady will have in her lifetime. So we measure it by, we only look at the ladies for this one. In these places, in these countries, you might have, there are still places, still countries on this earth where it's not unusual for a woman to have maybe 6 or 7 or 8 kids in her life. You know, here in our country, we think that's sort of unusual. That is not the normal. Like my family, I have 7 siblings. That we are an odd family. But in other places, that's totally regular. Typically, in these places, women will start having children. So they'll have their first baby at a relatively young age. So y'all are, what are y'all? Like 15 years old, 14 to 16-year-old, depending on what grade you're in. In certain countries, you would already have a baby. You would already be married. You maybe would have 1 baby or maybe 2, and that would be what is expected. All right, places like this: Kenya, the DRC, which is the Democratic Republic of the Congo, Ethiopia, Mexico a long time ago. This is 1970. It's obviously changed since then. Places like this. So typically these are developing nations. They have poor economies. Usually women aren't real active in their economy. and stuff like that. All right. Another characteristic of places like this, and part of the reason the fertility rate is so high, countries like this typically have a much higher mortality rate for their children, which means more of their little kids, their babies, will die young, which is why culturally it adds that I guess not need, but that sort of drives people having big families, because some of your babies might not survive. And it's important for a lot of societies that you have children so that your name can be carried on, or they can help you as you get older. Something to think about, right? The consequence of rapid growth, like we've already said, is that you might use up all this stuff that you have, all right? You might not be able to produce enough food for everyone, or enough clean water, or have enough space or jobs. So we want to be careful with rapid growth. It's not, when we're talking about people, it's not always a good thing, all right? We want to make sure that our growth is stable. Our next pyramid is stable or slow growth. So instead of looking like a big triangle where you have a lot here and then it gets really small, for this one, it's mostly like a column. It goes straight up and down on both sides, and then it starts to get smaller as you get up here. So here, in countries like this, or places that have this kind of growth, most of your babies that are born and most of your young people are going to survive into adulthood. You only start seeing a lot of people die when they start getting up here into their 70s and 80s, so they're dying of old age. They're not dying because they got sick as babies. They didn't get things like measles or malaria, or they died of malnutrition. Everything's kind of equal. Your birth rate, so how many babies are being born, is equal to your death rate. All right? The fertility rate for places like this are going to be 2. Now you might be saying, well, fertility rate is per woman. So why do I need 2 children per woman? Because it takes 2 parents to make 1 baby. All right? So if you have 2 kids, you replace both parents. And then you'll have stable growth. And that's kind of what you want. The United States is currently like this. Our population is slowly growing. But what's interesting is our birth rate is actually a lot lower than our death rate. All right, our fertility rate isn't 2, it's less than that. The only reason that we're able to keep up this stable population and this slow growth is because we have folks who immigrate or move here. And that's really beneficial for us in the long run, because that means we're going to have enough workers to work in our economy, and that's going to help support our elderly people when they start to retire, which is awesome. All right. And our last type of population is shrinking. So shrinking means small. It's getting smaller. So instead of having a column that goes straight up and down, you have a little base, and then it gets bigger, and then it gets small. So you have really not a whole lot of people being born. This is a big deal. And you might be saying, why is it a big deal? I thought we didn't want the population to grow. Well, we don't want it to shrink either, which is kind of weird. We sort of want a happy in between. The big problem with the shrinking population isn't so much the environment, it's the economic. So, a lot of places in Europe are dealing with this right now. France was dealing with this back at the turn of this last century, the 2000s. And Japan has a major problem with this. So, in Japan, let's talk about the culture of it real fast. Or not the culture, but the economic circumstance of Japan. Back in the 80s, Japan experienced what's called a recession, so the economy got kind of bad for a while. So families, they started having to have both parents work outside the house, so mom and dad would have to go away. And it's really expensive to take care of a baby, to raise a baby, to make sure they get the right schooling and can go to daycare and stuff like that. So in Japan, a lot of people dealt with that expense by just putting off having kids. They're like, I'm not going to have a kid until I get my career started. I'll just put it off a few years, and then a lot of people end up not having kids at all. A lot of people have to stay home or can't necessarily move out because they have to take care of their elderly parents. In Japan, a lot of people are starting to retire, but they don't have anywhere to go. There's not enough space in the nursing homes. Again, their kids have to work to make ends meet, so they can't take care of them. So it's a huge problem for society to have a shrinking population. It can cause a lot of problems too. So that's where I'm going to end today. On this last slide, there is this really cool TED Talk. It's about 10 minutes long. I invite you to watch it. I'll just give you a little synopsis of it. It's this guy. He's from Sweden. He has this cool accent, which is awesome. But he talks about how the population has grown and how the economics of the world affects growth. And he uses visuals and means of transportation. Basically, what he says, right now, the way it's going, we're going to have too many people in the world. You know, if we get to 9 billion, if we still have a lot of people living in dire poverty, so they have to walk everywhere they go. They can't afford a bicycle or a car or anything like that. If they have to worry about how are they going to eat that day, if they're not able to get good education, that's going to be a big problem. But if we can help people by providing good education, economic opportunity, especially for women, and help with things like family planning, so helping people decide how many kids they're going to have. Are they going to have a big family, or maybe they only want a little family, or maybe they don't want a family right now. And providing education and making sure that kids who are born survive, so lowering that infant mortality, is going to help us stabilize the population to where we need it to be, which is going to be about 9 billion. So tomorrow we're going to watch a super fun documentary called World in Balance, and we're going to look at all this again. So bring any questions you have tomorrow, and I will see you then. Okay, bye.